When Batuhan says it's okay, I will start.
Mhm.
I'm waiting for his text. Of the people here right now, everyone listening. In this week's webinar, we will be having Mr. Jan Fischer as our guest. Our webinar is about cost management in shipbuilding. We are very thankful to Jan Fischer for accepting being here with us today. Can you introduce yourself about yourself?
Arfe, can you repeat the last part again? The internet connection is weak.
I'm so sorry. I was saying, I was welcoming everybody, and then thank you, Jan Fischer, for accepting our invitation and coming here today. Before we start, can you tell us a little bit about yourself?
Yes, okay, I'm happy to do so. That's the first part of the presentation. So if you like, I can take over and start with the presentation. And of course, I also like to welcome everybody and thank you very much for organizing and introducing. What I prepared is this agenda. So first of all, I would like to tell you a little bit about the company's background and my background. And then I would like to give you an overview on the topic of cost estimation and cost management in shipbuilding. So I would like to begin with, with a question, why and how can we support cost estimation in shipbuilding, new building projects especially. And then I like to give you an overview on the CostFact software system. And then I selected some topics for a more detailed presentation. So this is bottom-up costing, regression analysis, and which reports can be created. And then I also have a showcase from Flensburger shipbuilders, how they calculated and optimized life cycle costs. And so regarding the background, there's a CostFact company was founded, I think it's now something like 12 or 13 years ago. And it specializes on cost management in shipbuilding. So it's exclusively focusing the shipbuilding market. And here's the new buildings. Our clients are, well, very widespread about the different types of ships. We have a lot of naval shipyards and also builders of super yachts, but also shipbuilders of special purpose vessels and commercial vessels. So up to now in Germany, the majority, so more than the half of the shipyards are using CostFact as a central tool in the cost estimation process. But also in other countries like Italy and Canada, India, we have clients which are using CostFact for cost estimation and cost optimization. Regarding the sizes of the shipyards, it's also very widespread. So the smallest one are, well, workshops with 30 persons overall. And on the upper side, also big shipyards like, for instance, ThyssenKrupp Marine Systems building surface vessels and submarines with nearly 4,000 employees in the meantime. So, and well, as an introduction into this topic, well, the question is, what is the need, or why do we have the need for cost estimates and cost management? And of course, it's always when there's a new project, it always starts with a tender. So somebody likes to build a ship, and the shipyard has to deliver a quote. And here, of course, a very central topic is quotation price. So that means very early in the beginning, so typically before the initial design started, the shipyard has to predict the price of the cost, and then accordingly the quotation price of the vessel. And that is pretty challenging, because at this very early stage, we have only very poor information. We have the requirements from the client, from the specification that the client shares, but we do not have the detailed information about the building process and all these things which causes cost. And at the same time, the project is typically very complex. So when you think about naval ships, have a very high complexity, and also a lot of different people are involved with their knowledge in the cost estimation. So we have the different trades. Some are for the hull building, other ones are for the propulsion system, and very different systems. And all this different knowledge has to be handled and managed to get one resulting quotation price. And in the same way, of course, all the time we have a high time pressure. So we do not have so much time, we do not have so much capacity for making these cost estimations. So on the one side, the complexity, a lot of different persons involved, and on the other side, only very few time to deliver this quote. So that is mainly about the cost estimation in the tendering process. But when we think at the next step to the cost optimization, so when we like to reduce the cost or to optimize the relation of the capabilities of a ship and the cost of building the ship, then it's quite worth to have a look at this chart here. So here we see on the timeline the different phases of the shipbuilding process. So it starts with initial design, then we have a detailed design, the engineering, and then later on the production, and then finally the launching of the vessel, and in the end the delivery to the client. And if you look at the bottom curve, the blue, dark blue curve, here we see the accumulated cost. So at which stage in the shipbuilding project or process the cost incur. So typically in the beginning, it's only few costs. Okay, we have the cost of the designers and the engineers, and then of course it depends if it's only a simple project or a complex project. But overall, we have only few costs in the beginning, and then when the production starts, then the curve is increasing, and then all the costs of the labor hours of the workers and the material and the deliveries from our suppliers causes costs, and the cost jumps up. So then finally, after launching, we still have some cost. But here that means that the majority of the cost will increase or will incur during the production. So and now when we look at the other curve, the red curve, that curve describes at which point in time and in the process of shipbuilding the costs are assigned. So when they are fixed. So here we see when the initial design is finished, we have already something like 90% of the cost already fixed. So we cannot change it later on. So when we are in the stage of production, we can consider, well, what is preferable? Is it purchasing by this a supplier or another one? We still can influence the cost, but only in a very small scope. So and that means when we think about optimizing the relation between cost and capabilities and how to reduce cost and how to get the most cost-efficient design, we have to do this very early in the initial phase. So, and that is once again challenging because at this point in time, we only have very few information that we can use for cost optimization. So, and that is a big challenge under this or before this background to optimize the cost. So, and here's a CostFact software system which supports this cost estimation and accordingly cost optimization in very early project stages. So before going into the details, I prepared this overview here. So what is this software system about? So here the first thing is that CostFact is capable to incorporate really all information which are relevant for cost management. So when we start at the bottom of this chart, so here we see the supplier quotations, we can import and administer and compare the quotations which are provided by the suppliers. And then when we go clockwise, we can have the specification. We can import the specification which we receive from our clients. So when there's a tender, a new project, we can import the specification in order to align the calculation, our design, exactly to the specification. And then very important, the incorporation of technical parameters. So then we have different design options and we want to select the one with the highest cost efficiency. It's of course important to incorporate the technical parameters, and that is also part of CostFact. So then we go to the unit rate. So it means now we look at the cost side, so we can administer the labor rates and material rates within CostFact. Especially important in the beginning when we start working with CostFact, we can import existing calculations from spreadsheets. So there's an interface to import calculations from Excel spreadsheets. So then we can connect CostFact to the ERP system in order to exchange data. So for instance, the next point, incorporation of the consumptions when the production is going on, the construction and the material and labor hours incur. So then we also have the possibility to work with different breakdown structures. So the Swabish codes, the elements, which are the backbone of each calculation and also of the design. So CostFact is capable to administer alternative different breakdown structures, and then projects can be transferred from one structure to another one. So when we look once again at the bottom of this chart, we can work with cost escalation. So for instance, if we reuse information, cost information generated 2 years ago, we can update them very, very easily to the current price level. So and of course, we can also make manual inputs in the system. And then very important and very big advantage of the system is when we look at the right side of this chart, when we work on a current project, we can always access very easily existing projects from the past, which are already calculated and available in CostFact, and then we can import and reuse information from these existing projects. And so the typical procedure when making a new cost prediction in CostFact, a new estimate, is not to make everything from the zero base, but instead we can browse through our existing projects and collect the parts together which are comparable to the new project. And so that is especially in the bidding phase very helpful. Instead of waiting for supplier quotes for some weeks, we can just browse through our existing information and collect the cost data together and configure our new project. And the second way to make use of existing information from past projects is to analyze them statistically. So here that is a regression analysis. And well, to use an example like shown here, it's about the cost of a propulsion system. So when we have 2 or 3 suppliers for our propulsion systems, and we already purchased a couple of them over the last years, we can analyze them, so existing projects, by defining in the first step what is probably the main cost driver for this object. And here in this example, when it's about the propulsion system, it is probably the requested power within one type of propulsion systems. So in the chart here in the middle shows how the existing systems are analyzed, and we are looking for a relation between the capability, or here in this case, requested power of the propulsion system, and then on the other axis, the costs which are caused by the system. So here in this example, each dot in the chart is one existing project, and here we see there's a relation between the requested power and the resulting cost. And with this, we can derive this regression function. And then when we look on the right side, if there's a new project and we only have the information, what is the requested propulsion power, we can use this function to make our cost prediction. So by inserting the requested power, we get the prediction of the according cost of this propulsion system. So finally, after all this, estimates on a high level, we will work in this detailed breakdown structure. So here we see the main calculation view of cost fact. On the left side, we have the breakdown structure. The blue elements are the elements of the Sweber's code. And then we populate this the structure with the black elements, which are the cost items or labor hours or the purchased material and these things. So on the left side, we have a structure. On the right side or on the center, all the different columns, we have the information about material cost and number of labor hours and the resulting labor cost. And we see on each level, on the final level with the black elements, we see the single components with their costs and quantities. And then these costs are summarized of the different levels. So here in this example, when the propulsion units is selected, so the selected row is 2,300. So the cost we see on the right side and the number of labor hours is the total, the sum of all subordinated elements and groups. So when we look on the topmost row, there we have the entire project. So here, sample project Bergen 2. Here we see we have overall total cost of, in this case, 33 million euros in this example. So that means we can address each level according to the point in time which is of interest. So probably in the beginning of an estimate, we will address the high levels and generate the cost by regression analysis or comparison with other projects. And then when proceeding in the project, we will go to the detailed level on the final levels, and we look at the distinct components. So here a summary of the different costing approaches in cost fact. So we have two top-down approaches and one bottom-up approach. The first top-down approach is here I call it analogy approach. So we are looking for similar projects and can we reuse information from past projects in a new project by importing them. And the other top-down approach is when we look at the functions, functionalities, and capabilities by applying the regression function, which we derive by analyzing existing projects. And the bottom-up approach, here I call it engineering approach, is when we really enter the single components, cost items, and then they are summarized to the top level, to the entire project. And in practice, usually these different approaches are combined. So at the beginning, we are working top-down, and then in a later step of the process, we switch to the engineering approach. So are there any questions so far to this overview, which I might answer? If there are no questions, I
actually, more of a general question. Someone asked in the chat if you could share the presentation with us.
Yes, sure. I will make a PDF file afterwards, and perhaps I send it to you, and you can make it available for all participants.
Thank you very much. Also, I have more of a different question. Maybe it's too time-consuming. If so, you don't have to answer.
Also, okay, so we have time at the end, so perhaps we can address your questions in the end, if it's time-consuming.
Okay.
Okay.
I'm not sure because
I can hardly hear you. Really... Can you say again, please?
I was going to ask if there is something similar to cost fact in other industries. If not, can cost fact spread to industries other than shipbuilding?
Okay. Yeah, I understand.
Yeah,
okay.
that's sweet.
Right. Okay. From my knowledge, CostFact is the only up-to-date software in shipbuilding. Outside of shipbuilding, there are lots and lots and lots of such programs. So if you look to the automotive industry, there, I don't know, 20, 25 different programs like this. And so there are a lot of software systems for cost estimation in other industries or general industries, so for everything usable. And that is a reason for CostFact to focus only on shipbuilding, because in the shipbuilding market, there's no competition, and then CostFact can specialize on it and brings a very, very high value, especially to shipbuilders. I believe outside of the shipbuilding market, CostFact value would be much reduced because there are other systems providing this and providing that. And that is why we focus on the shipbuilding market and incorporate all the knowledge from our users. And we have in the meantime a major number of shipyards working with CostFact, and they are all bringing their demands and requirements into the systems, and they are all shipyard specific. And that is for us the reason to say we are only for shipbuilder.
There are two more questions. If you want to, we can answer them now. I can ask them now, or you can answer them later. Okay. Someone asked if cost estimation can be made based on SFI codes.
Yes, yes. So the breakdown structure, which you saw beforehand, that is the first step when installing CostFact, is to import your own structure. And we have several users which have the SFI structure, and they're working with CostFact with the SFI structure. Yeah.
There is one more question, and they want to know, how does CostFact know the dynamics inside of a shipyard? Because that is a game changer that plays a huge role in how things play out.
What is meant with inside dynamics? So is it the plants within the shipyard?
I think they're talking about. I think they're talking about every shipyard kind of has their own way of working, their own plans.
I believe I understand. Yeah. Okay. So CostFact itself.
Basically, what differentiates them.
Yeah. All right. So CostFact comes not along with numbers about how much time consuming is it to make a weld or something like this. CostFact is only a shell for the data from the shipyard. So the shipyard will upload their own data about the unit rates or about norms. So all shipyards have their norm tables where it says, well, for us, it takes one meter welding is 35 minutes. And the other shipyard has another system and it takes 25 minutes. And this specific data can be uploaded into CostFact. And then each shipyard works with its own data.
Thank you.
Okay.
Thank you.
Good. If there are no more questions, I continue with parametric costing and regression analysis. So here the approach.
Currently, there are no questions.
Okay, good. So here the idea is that we have, so we have here in the center bar, we have the different groups. So here that could be also from the SFI, for instance. And when we have, for instance, the hull or the machinery and propulsion, there are probably distinct features or drivers influencing the costs. And so the first step is to think about, and probably all shipyards already did so, to say, well, what is a cost driver for the hull? So that it's probably the dimensions of the ships and these things, or the deck area. For machinery, propulsion, it will be the speed, requested power, and so on and so on. So here we have the function or the capacities, which are the cost drivers, and to be analyzed. And the same is, of course, for the technical parameters. So here we see in the entry window where we enter the technical parameters of a ship. So here we are looking at a specific project, and here we can enter the dimensions, for instance, which we already know. So the first one, length overall, is in this case 70 meters, and so on. So that is entered here centrally for this project. And okay, there are some things like consistency checks. So perhaps if somebody makes a mistake, he will get alert, take care, check this parameter again. You can also import this information from the CAD system, so from the design model, if there's already design information available in the design model. So we have an incorporation with Ship Constructor, but the interface that is general usable can import also from other design systems, design data. And then based on this data, on this technical parameters and design data information, cost can be calculated. So when we look here at the form in the background on the bottom, here we see the line with the labor hour steel work. So here we have to calculate, we have to estimate the number of labor hours for steel work. So the one approach is to enter it manually, to say, well, I believe it will be 100,000 labor hours, so I can enter the number manually. But in this case, we have cost norms or norm functions in this function pool. And so the user can pull up the window which is shown on the top, and here is defined the shipyard specific relations. And here it is said, we can calculate the number of labor hours for steel work based on the total steel mass. So in here, the function on the right side is that we say for 1 ton steel, so that is x1, for 1 ton steel requires 140 labor hours steel work, and plus 200 some setup additional work. So, and then the user can select this function, this formula, and based on the centrally entered steel mass, which we entered before or imported from the design system, and this formula, the resulting number of labor hours is calculated. So then we have the labor rate, and then accordingly the cost of all. So but that means if later on perhaps a design change takes place as the number of steel mass changes, of course the calculation will be updated automatically. Or another example is if you reuse an existing project as a template for a new one, you would just make a copy of it, and then you can update the technical parameters. And based on these formulas, the new project will be recalculated or will be calculated automatically. So this requires, of course, that we enter for all the different cost items such a formula or select a formula from the norm pool. And probably, or in practice, this is not always given. And we might have also cost items which are not linked to such a formula. They are just manually entered, the values. But even in this case, cost fact has a feature to to parameterize such cost. So based on the template, so here we have on the left side, the blue project might be a template with technical parameters and cost. And then if we reuse it for a new project and we change the technical parameters, we change the length, we change the GT, the gross tonnage, and these things, and then cost fact can propose a parameterization even if there are no formulas in the background. So cost fact compares both designs and says, based on the increasement of the length overall, the following cost items should be increased in their number. So then the user can go through this list and check the proposed values and can confirm or decline, and then the new project can be calculated. So, and the idea of this is, by this procedure, that we do not have, when we calculate here on the left side, a new project, do not have to enter everything, but we just make a copy of an existing project, update the technical parameters in the central administration, well, and then the rest is done by cost fact. Then we click on the button, and cost fact parameterizes the calculation, and we have the new project calculator. So on the right side of this chart, so design changes in the current project, if the user, the client requests a design change, we can just update cost fact based on the design changes made in the design model, and by applying this feature for parametrization, the cost calculation can be updated by itself. So the user, well, just clicking a button, but then of course controlling the result, confirming, and we have all changes incorporated in the new project. So then the next question might be, okay, when we like to make use of such formulas, of such cost norms, how can we create them? I already mentioned cost fact is empty. It does not provide such data because they are shipyard specific, and it was already said in the question. And so typically in the first step, when cost fact is implemented, we will import our existing projects from Excel templates to make them available in cost fact, and then we can analyze them. So here we have a very, very simple example, typical for super yachts, where the user says, well, we believe that the total cost of the entire yacht depends mainly on the length overall. Well, that is one example that was very common in Germany over some years. I think it would be more preferable to work with a GT, but anyway, the procedure is the same. So here we have our existing projects available in cost fact, and then we select the technical parameter, and we select on the other side, what do we like to analyze? So here in this case, a total production cost. So here in this case, we see, okay, there's not a cloud, there's the different projects lying more or less on a row, on a line. Then we can calculate this regression function. So, and that is the idea, to make this regression function available in this way. And in cost fact, it looks like this. So here we have one window where all this takes place. It's 4 or 5 different steps. And the first step is to select, so here in the upper left corner, to select the regression parameters. So in the first step, the user selects the group which should be analyzed. So here in this case, only one group is selected, the propulsion plant, group 2000 here in this breakdown structure. It could be also the entire project, and we are also able to combine different groups. But in this case, it's just group 2000. And after selecting this group, in the next tables, under the first ones, we see the parameters. So, and after selecting the group 2000 propulsion plant, we see here 3 different technical parameters available to be selected. So here's the length overall, the propulsion power, and the speed. So that is defined by the administrator that these 3 different parameters might have an influence on the propulsion power. And on the other list, on the right side, so here we can select, what do we like to analyze? Do we like to analyze material costs or labor costs? Or here in this case, selected the production cost, which is the total of material and labor costs. But it would be also possible to select the labor hours. So for instance, if we select the hull and we are interested in analyzing the number of labor hours for hull work, we can select the labor hours as well. So here in this case, the user selected propulsion power as a cost driving parameter and likes to analyze the production cost. And after confirming, we now see all projects in cost fact which are already calculated and provides information on the propulsion power. So we see them on the list on the left side and also in the chart on the right side. So in the chart, we see each calculated project as one blue dot. And there we see the x-axis is the propulsion power and the production cost on the other axis. So, and then it's up to the user to define, can I use this project? So of course it can also be filtered. So you see on the left side, we can define ship types. And then if a shipyard builds different types of ship, probably the first step is to limit it to the relevant ship type. But then in the next step, it's also up to the user to analyze this sample data and to define, can I use it, yes or no? So, and here in this case, you see there's one outlier. And so the next step will probably be to select this outlier in the list and pull up the calculation short view. Perhaps the user identifies, okay, that was another type of propulsion system and it's not comparable to our standard systems. So the user deselects it in the list. And you see it in the chart still available, but it turns to a gray X, so it will not run into the analysis anymore. In the same way, we can use the slider on the top of the chart to exclude entire ranges. So then finally, when we are confident with the resulting sample data, we can continue, and after clicking on calculate regression, COSFAC calculates 4 different regression types. So here we have linear, potential, logarithmic, and exponential regression types. These are functions which are typical in practical application cases. So, and COSFAC also calculates a so-called stability index. So that just a value expressing how good does this function fits or matches the different points. So, and then COSFAC proposes the function with the highest stability index. In this case, it's a logarithmic one. Then it's up to the user to continue with this one. It could be also possible to say, no, I believe it's a linear relation. But here in this case, propulsion power and production cost, it's probably a logarithmic relation. So 10% more power is probably a bit less than 10% more cost. So we proceed with this one. Okay, the user can analyze it a little bit. Very important in this case or in this context is to keep in mind that it's still up to the user to to assess, can I work with this result, yes or no? COSFAC will always offer you a regression function, even with only 2 dots. COSFAC will show you a line going through these 2 dots, stability index of 100%. But of course, it's up to the user to say, with my knowledge as user and as engineer or estimation expert, are these existing projects comparable with a new one? That's up to the user. So, but here in this case, the user thinks, yes, fine, I can work with this sample data, select the logarithmic function. So, and then there are different ways how to make use of this result. So the very easy one is we have a current application case. So we are just calculating a propulsion system, and we have the request of 9,500 kilowatts. So we can enter this value, and based on this regression function, the prospective costs are estimated or calculated and shown, and we can enter this result into our calculation. So by doing so, it's not part of the presentation because it's an advanced feature. COSFAC can split it up by comparing with a reference vessel, so can create labor hours and all these things combined with this total cost and enter the result into the calculation. But we can also, if you look on the upper left corner of this chart with a menu bar, we can add it to the norm. So we can save this function in the norm pool. And that means we make it available also for other users, and we can use it in other projects to calculate the prospective cost based on the propulsion power. Yeah, that was about regression function. In general, you can also do this, I think, with Excel also offers such a feature. Here, the main advantage of COSFAC, of course, is that you have everything in one system. You can make use of things like, well, I haven't explained it, but you see it on the left side, you can escalate the cost. So perhaps these past projects, perhaps they spread over the last 3 or 5 years. They were calculated in different price levels. But in COSFAC, each project has mandatory a date assigned, which is a price level date. And then you can escalate them based on escalation factors, depending on the cost classes, to a defined price level. So all this is done in the background when COSFAC calculates such regression functions. Okay, the next thing, a short thing, is a bottom-up costing. Here just selected an example from a lot of different features. But here we see the calculation view in total. So as we see it in the preview or in the overview, on the left side, the breakdown structure, then in the center, the different columns. On the right side, we have possibilities to analyze the calculation, to apply filters and these things. And here, what I'd just like to show very briefly is how a new calculation can be created by this analogy approach when I import information from other projects. So here in this case, I created a project entirely new. So it's not very typical. I think in most cases, we'll make a copy of an existing project and then modify it. But here, to increase the overview, I created a new project in the project administration. I open it, and then it automatically have on the left side the breakdown structure, which is defined as our basic breakdown structure, which might be SSI, for instance. Here I have another one from the German Navy. So then in the next step, instead of entering everything manually, we can say, well, let's have a look. Is there already information available from other projects? So in here, in this case, I start once again with a propulsion plant, number 2000, select it in the tree, click right, and then I see this context menu. So here's one menu item, import cost. So when I click on this, I see a list where I have all the different projects which are already available in cost factor listed. So now in the next step, I will probably filter them. So here you see on the top bar, we have filtered them by the propulsion power and applied a filter. I will only see projects with at least 7,500 kilowatts. So and then the list is filtered. Here you can also pull up an overview of these costs which are in these comparison projects. But then when I analyze them, I think, yes, this one which is selected here, that is comparable to a new one, I can confirm with select project. So then cost fact runs in the background a consistency check. Are there differences regarding price level, regarding escalation factors, or these parameters, are perhaps formulas applied which are not applicable in the current project because there are parameters missing and such things. So I have on the left side these traffic lights showing me to perhaps have to deselect something. So on the right side, I can define the import. What do I like to import? Perhaps everything, or perhaps do I like to limit it to a selected cost class? And I can also do things like apply a cost escalation. So to update the imported cost to the current price level, or to parameterize the cost based on different technical parameters. So that is controlled on the right side. And then when I make my settings, I just confirm with clicking cost import. So then I have this part of the project imported into the current one. So that is a very efficient procedure to make in a first step, instead of entering things, new quotes from suppliers, just browsing through the breakdown structure on the left side and collecting this information together. So the last feature I selected to show here in this overview, the entire presentation with all features, something like 3.5 hours, is the possibility to calculate variance. So for instance, you have a simple design, or the other way, you have a basic design, then you like to reduce cost. Then you can deselect, or you can define a new a new variant, and in this separate variant, you can deselect cost items or entire groups. And then finally, you can contrast or compare both variants, and then you see the differences in the cost. And perhaps then you can make two different quotations to your supplier. The first one, which matches exactly the specification, and then perhaps another one where, with your own knowledge, it's only a very, very small reduction of the capability, but a great reduction in cost. Then you can perhaps propose it as an alternative to the basic design. So that is a basic approach from cost fact, different costing approaches. Here in the next chart, I just have some samples for reports collected together to give you some impression what can be the result of such a calculation. So for instance, in this report, we get an overview of the total cost and how they break down of the different cost classes, which can be defined shipyard specific. So we see what is the influence of supplier or of the purchase purchased material and what is our own contribution to the total cost. We can also, well, it was not shown now in the introduction, we can define milestones, and we can dedicate the cost to different project phases or periods, so down to the single month of a calendar year. And then we can analyze the cost incurrence over the timeline, or also the incurrence of the labor hours. So we can gain an insight into the labor hours which will be requested internally in our own shipyard by such a project. So then we can also enter the expected incomes, so the revenues from our client. So when we think about financing costs, on the one side we have our cash out, and then of course it's important to have the cash in negotiated with the client in a way that we are always on a good side. So here in this case we see the blue line is our cash out, our costs, and the other one is the incomes, the payments from our client. And here we see we have financing costs because we have our payments, or the revenues from the clients are too late. So we have probably to try to negotiate with them to get earlier our revenue. So once again, a pie chart. I'm not a fan of pie charts, but here it is. So that is about the different currencies. So you can enter the cost also in different currencies. If you have a supplier which is not quoting in your case Turkish lira, but another currency, you can enter the quote in the original currency. Then it can be converted into your basic currency. But then you can analyze the calculation. What is the portion, the part of other currencies? So of course, very important in terms of the exchange rate risk. So when you offer, or when you quote your project, and 2 years later, the construction will take place, and the exchange rates change in the meantime, might be risky. And with this analysis, you can gain insight in such risks. So this next one, that is this typical Pareto analysis. So when we think about how to reduce costs, then we're of course interested in what are the most or the components with the highest cost. And here we can select in the first step the part of the project we are mostly interested in, or also perhaps the entire project. And then this analysis shows us the most the components or tasks with the highest cost on the top. And here in this example we see, so that's from inland vessel, it's only one group, but here we see that the crane is the most costing a component in this group, 1,600. And we also see that we only have to address nine components to cover already 80% of the total cost. So on the right side we have the cost accumulated. So we see with only nine components already cover 80% of the total cost. So we will address these one, perhaps try to is an alternative system that can be used that is more cost efficient. So this very colorful chart is about risk and opportunities. So you can define risk and opportunities, and then you can assign these risks and opportunities to the different cost items. And then here we can analyze them. And so here in this case, we see, well, on the list on the upper left side, we see that we have 46 million euros here in this euro example, which are assigned to risk class 2, so very low risk. And well, but we see also in the chart there are some components or systems with a very high risk, which are assigned to 20% risk. So, and the toggle chart in the middle shows us the number of items, and here which is currently selected with a 48 in the center. So that is well, here we have the information from the column that is a risk class with 12%. And these are the cost items which are between 50,000 and 100,000 euro. So we see there are 48 cost items in this combination with pretty high risk and high cost. And when we select or click on this toggle bar, we see them on the list on the bottom. And then we can go in depth in the next step and try to figure out why is the risk too high, is there any possibility to reduce the risk. So then finally, the last chart, that is about target costing, one of my favorite approaches in costing, so that we define absolutely in the beginning, before we start our cost estimates, to set a cost target, to have the idea, well, what do we like to allow the project to have a cost? What do we believe, what is the cost that we have to achieve to get this project? Of course, we have to fulfill all the requirements from the specification, no question. But we have probably a couple of competitors, and we want to have this project. And if we fulfill the specification requirements, we will get it if we are the one with the lowest cost. And what do we believe? What is the cost we do have to achieve to get this project? So that is the first step. So here in this case, we believe when we are able to build the ship for 38 million, then we will get the project. So and then we enter this 38 million here in the first column on the top. In the next step, this target cost, or this cost target, is broken down of the different main groups. So based on the comparison with existing projects or knowledge. And then based on this total target cost and the breakdown, we have target costs for all single main groups. So probably we have also different responsibilities for the different main groups. So that is the first step. So and then we make our cost prediction, and then automatically the next column is filled. That is the planned cost. So the numbers in the column planned cost, these are the same numbers we have in our calculation view. So based on our initial target cost and our first design and our first cost estimate based on this first design idea, we have the planned cost. So then we can already make a comparison and see, in this case, we have a cost overrun on the topmost row, a cost overrun of 8%. So we overrun our target cost by 8%. So that is the information we already gained at this very, very early stage, where we still have the possibility to influence the cost, to consider about alternatives for systems or for design decisions. And in this situation, when we see we have a cost overrun by 8%, instead of saying, okay, everybody has to reduce cost by 8%, that is not very efficient. If there's a main engine and that causes this cost, and you know it's already negotiated, there's no chance, you cannot change it. And instead of going this way, everything reducing by 8%, we can go, based on our information, by this cost breakdown, we can go on the next level and analyze, well, where does this cost overrun result from? And here in this case, we see we have a very high cost overrun in the hull structure. And then we will go into this major group and we'll analyze it. What is the reason that we have such a high cost overrun here? And that will hopefully help us to get ideas how to reduce this, how to find alternatives. But we can go much more straightforward to the problems compared to a procedure, everybody reducing by 8%. So in the next column in this chart, that is then you can also compare, of course, the actual cost when the construction is running and the cost incurred, the labor hours incurred, then you can also compare it with the target cost. But if you remember one of the very first charts, the main influence is at the beginning of the project, and that is the very first column. So in the beginning, comparison between target cost and the planned cost. So then finally, we still have 4 minutes. I think it is the last chapter with a showcase from Flensburger shipbuilders. And here we're looking at the total life cycle cost. So up to now, we only had a look at the construction cost, so the building of the ship. And life cycle costing, here's the approach is to say, okay, we make a change of the view. We are not only looking from the shipyard side, the cost that incur on our side, we try to see it from the customer side, the client who is buying the ship. And for the client, the investment in the beginning, so the amount paying to us, to the shipyard, is probably only a small amount compared to the total cost of ownership. So the entire cost which incur every year during the in-service phase for running the ship, for the operation, for the crew, for maintenance, for sustaining maintenance and replacements after some years. So, and typically the idea of the client is to try to reduce the total cost of ownership. And sometimes it might have happen that it means that increasing the investment cost, so the cost for the shipyard for building the ship, will lead to a reduction of the operation cost. So for instance, typically for naval ships, the degree of automatization. If you have a high automatization, you have higher initial cost for building the ship, for the automatization. But then you can operate with a reduced crew. The crew number can be smaller, and that means operation cost is reduced. So then it can be very helpful to say, okay, is it sensible, is it reasonable to pay 2 million more for the automatization, and then you can reduce the crew number by 2 persons, for instance. So for firefighting and such things, where you need the crew for. Or another thing is, of course, things like long living components which require less maintenance and these things. So, and that is the target of the life cycle costing, to incorporate this relations between of design decisions. And here in this example, it was a practical project. So Flensburger shipbuilders, they quoted for a supply vessel for the British government, for the Ministry of Defense, and there was the specification and the MOD. They said, together with specification, they said, well, here's our specification, and of course we like to receive a quote which fulfills all our requirements. But on the other side, you, the shipyard, you are the experts. If you have an idea how you can reduce costs dramatically, and it's still okay with our requirements, then please tell us. And here in this case, Flensburger did so by comparing 2 different variants. And they had a basic design, which fulfills exactly the requirements of the specification, and then an alternative design with a little bit reduced functionality. And one thing was that this alternative design has only a 1-screw propulsion system instead of the original requested 2-screw vessel. So, and then for both variants, Flensburger calculated the life cycle cost. And here's the main entry window for the life cycle cost. So on the upper side, we have the payments before the operation, and on the bottom, the payments, or in this case, incomes for reselling. But the panel of highest interest is the table in the center, where you see in the first column the different payment types. So here we have personal, fuel oil, lap oil, regular maintenance, sustaining maintenance, and so on. And then we have the different periods, the different years of in-service phases. So, and then it's up to the shipyards to look into the crystal ball and to predict the cost for the different in-service costs. So they are entered here, and then based on the interest rate, the cash value is calculated. The cash value is discounting all the costs which are after our relevant period, which is in this case year number 0, that is a delivery of the ship, and that's just to make different life cycle durations comparable. So here in this case, we have the result. If you look on the bottom right side, we have as a result a cash value, so the total life cycle cost discounted to year number 0 of 136 million. So for itself, this information has not much value, so or not much worth. So 136 million, is it much? Is it less? So it starts getting interesting when you compare it with an alternative. So, and this is shown here in this window, where the both different variants are compared. So the red one, that is the more expensive one, the 2-screw vessel, and the blue one is the 1-screw vessel. So, and as you see, we have in both cases 2 lines. So Costek is also capable to calculate with best and worst case scenarios. So to incorporate uncertainties during the in-service phase. But here in this case, well, this result is fictional. That's not the real data from Flensburgers. Here in this case, we see that the blue one, so the 1-screw vessel, is in any case, even in its worst case scenario, less expensive than the other one. So, it starts on the left side. It starts with the investment cost, so the cost of the shipyard plus the profit, and then we see here over the years, in this case 17 in-service years, we see the in-service cost. So, and based on this information, so here we have the cost for the total life cycle, and then there is the technical value, which is shown here in the chart on the x-axis, the technical value, where we compare the 1-screw and the 2-screw vessel. And here we only have 2 different variants, so it's easy. The 2-screw vessel fulfills the requirements to 100%, so it gets 100%, so it's on the right corner of this chart. And then the 1-screw vessel, it was calculated based on a scoring system for the different requirements. And where it does not fulfill the requirement, it was accordingly less rated. And then overall, in this example, it's also not exactly from Flensburger because it's confidential, but here we see it's somewhere at 70% compared to the 2-screw vessel. So then the other axis here is the economical value, so the costing side. And here it's just easy to say, well, the 1-screw vessel, that is the one with a lower cost, it gets 100%. And then the 2-screw vessel might be 15% more expensive, so it reduced. And by placing both variants on the chart, we can compare them. And then it's up to the client to say, well, what is more important for me? I see I have something like 10 or 15% decreasement of cost, but something like 30% decreasement of the requirements. Pardon, it was not by instance. No, here we are. So, and then it's up to the client to select which one is the one with the overall highest overall value. Okay, that was it. I run a little bit late, 5 minutes, but perhaps you still have some question, and if you like to ask something, I'll try to answer.
Right now, there are no questions in chat.
No question in chat? Okay. Well, as I agreed, I can share this PDF file, and if somebody might have a question afterwards, there's my email address also. Everybody is, of course, very welcome to come with this question.
There is one question right now. I can read it to you. Can we be able to see other users' cost statistics, like shipyards building the same type of vessels in Costek?
I'm sorry, no. So that's a very typical question. Of course, it would be of a very high interest for a shipyard to look at other shipyards. But of course, I have a lot of insight into these things. But every shipyard knows that this is kind of confidential, and so. We once started, that's something like 7 or 8 years ago. The idea was to make a benchmark. It was together with Technical University Berlin. The idea was to bring some shipyards together and also ship operators. So when thinking about life cycle costing, and there were a number of shipyards very excited about this, and we started with it, and they were all very interested to get the results. But it was a disaster because no shipyard was willing to share information. So I think that is, well, it would be nice, but unfortunately, I cannot provide such thing.
One more question came just now. Mm-hmm. How does the program work for state-of-art unique projects like hydrogen-ready and methane-ready vessels?
Yeah, okay. But in this case, if it's really completely new and there are no past projects at all to compare, then of course you cannot make use of things like this regression analysis or importing from other projects. Then you cannot use these features of cost. Anyway, I know from shipyards. So, for instance, we had in Germany, it started something like 3 or 4 years ago, and it was about multi-purpose vessels. It was the biggest project of the German naval ever, since the last war. And that was the point in time that all naval shipyards in Germany, which were not COSFACT clients so far, started with COSFACT. And some of them said, no, we have projects from the past, but here in this case, we'd like to start from the scratch. We do not reuse information from existing projects, but COSFACT allows us to enter everything in detail, to enter or to calculate variance. We can also work with uncertainty. That is something that is not shown here in this presentation. So if something is completely new, probably the uncertainty is higher. So you have to make assumptions. And you might say, okay, now I have this number entered into COSFACT, but it can be plus minus 20% in the end. And COSFACT has a very sophisticated feature to address such uncertainties. So you can work with reliability classes, and later on you can make an analysis which shows you, well, your resulting cost is 120 million, and the prospective forecast error is plus minus 7%. And that is also very helpful. And then you can decide, well, that is okay for the moment, or no, plus minus 7% is too much. And we have to go more in detail in this components and systems which are responsible for this uncertainty. Yeah. So in summary, some of the features of COSFACT require that there are comparable projects. But even if there's completely new and somebody starts with a zero-based budgeting from the scratch, there are also a lot of features which makes much more comfortable and reliable compared to entering the values in an Excel spreadsheet.
Right now, there aren't any more questions. Also, the friend who asked the question says thank you also.
Okay, when there are no more questions, I would like to thank you very much for joining. I also had I discovered how to show the number of users, and I saw that it was quite some audience. Of course, I'm very happy about this. And as I offered you, if somebody later on has a question, please always feel free to contact me. And also, if some of you are working in a shipyard and you're interested to try COSFACT, so there's no free trial version. The reason is just it needs a little bit training. So we have a standard package, and the first step is a 3-hour training. It can be also done virtually, of course, and then it's then everybody can try COSFACT by themselves, and also import existing data from the own shipyard. So it's not a cloud solution where you must be afraid about confidentiality. It's always installed in the environment of the shipyards, and everybody, who likes to try it can also come back to that.
Thank you very much for responding to our invitation. We wouldn't have been able to have such a webinar for us too. If this were the normal times before COVID, we would be taking pictures.
Mm-hmm.
However, because we can't do it that way, I will be asking my friends who are available to open their cameras, and I will take a screenshot of us.
Okay.
I think we can stop streaming on YouTube.
Okay, yeah, sorry. So I say stop sharing. Yeah.
Arkadaşlar müsait olanlarınız kameralarını açabilirlerse, Aykut YouTube yayınını kapatabilirsek.